carry on with live data collection on Windows. So there's three options. Use a pre-built kit. Your book often talks about this Mandiant Redline product, which I was never able to get to work well enough to do any good. But now we have Velociraptor, which really works and is wonderful. And that's what we're going to use primarily. You could, of course, create your own collection tools, but I would recommend doing that inside Velociraptor. Velociraptor has the ability for you to modify the scripts if you want to, but for everything we're doing in this class, you'll be able to just use the pre-written scripts that are already there in Velociraptor. Those are really very good, and you don't really need to customize them for most cases. So Mandiant Redline, you'd install this thing and create a collector and then run a collector on the system which would collect the data. That was the old-fashioned manual process of Mandiant. Velociraptor does it all automatically over the network. It's much easier. You could make your own toolkit. Boot from like a CD or just put a bunch of things on a thumb drive, plug it in and run from there, that sort of thing. And there are toolkits. Microsoft made one at one time called Coffee. There are special Linux distributions just for this purpose. There's lots of ways to do it. And you use tools like date and time to get the time, system info for the time zone and all this stuff, net user and net group for user accounts, IP config and route and ARP and netstat to record network information. You know, these are what you do. Just write a script that runs all these things and puts all the output in a text file, and that would be a profile of the system. And there's a lot more things you can do. You can get third-party tools to list network connections and services and drivers and processes and event logs and all that jazz. There's built-in Windows systems, and there's Microsoft sysinternals tools. There's a lot of good tools to do this stuff. And this is all any tool would do. And this is, by the way, all Velociraptor is going to do, is download appropriate tools, typically from Microsoft sysinternals, and run them and collect the data for you. It just gives you a nice graphical environment where you can point and click on things to do that, and you don't have to write your own script. Prefetch is another good thing. The Prefetch folder saves a shortcut for every program that has been recently launched in a Windows environment, so that shows you a nice list of who's been running what on that machine. Restore points have backups of files, so this is good to recover the previous versions of files or copies of files that were deleted, for example, because a bad guy was trying to cover their tracks, browser history, and so on. So you often would write your tool in some kind of scripting language. The simplest thing would be to just use MS-DOS batch files. That would run with using native tools and have the minimum amount of effect on the system. If your machines have these other languages installed, like Python or something, you could use them. VBScript is included at least in older Windows versions. I'm not sure it's still there in Windows 10, but it's another option if you want to use that. So, log everything that your script does. Don't just record the output, record what tool was executed and have a checksum of the collected data to make sure that it's accurate. Test your script on a test system, to make sure it works. And if you want to collect the memory from the system, then you'll need to run a special tool. And so there's quite a few of them out there. FTK Imager can do it. Memorize can do it. And Belgasoft RAM Capture is one I learned about recently from that article I pointed you to. They said it was really a good one, and I used it, and it really is very nice. I found it worked very well on Azure, and some of the others didn't. And then there's some Mandiant Memorize is a command line tool, and you can just copy the data from the system with it. FTK Imager Lite, you can just use a GUI and make a memory capture image from this. It's easy enough to do. You could also dump the memory from just an individual process. There are quite a few tools that can do that. There's a Microsoft tool called ProcDump that will do it from sysinternals, part of Microsoft, but there's other tools that can do it too. Each running process has its own allocated memory in both Linux and Windows and any other operating system. You can find it and you can read that memory. Velexity. Oh yeah, I think I've heard of Velexity, but I have not used it. Yeah, that's good. Anyway, one thing I did, I had this in my old forensics class, I don't think I've got it in this class, you can run TeamViewer and you'll find this key is in there, 215-080-832. You can find that key in there. It's just sitting there. Surge is the memory dumping tool. Okay, cool. Thank you. And anyway, and also I found out recently if you type your password and log in to an email account in Opera, you can also find the password, or most of the password, intact in the memory of the Opera process. So it's kind of good, clean fun. I did that years ago for Chrome at Hope. Chrome no longer stores passwords in memory, at least not when I tried it a couple of years ago. Anyway, so on Unix-based systems, of course, Unix or Linux, none of these automated tools are going to work, although I think Velociraptor might. It does have a Linux agent. But anyway, you can make your own tools. Really, you just write your own scripts. Write a bash shell script or something that runs what you want, although some of that's already in Velociraptor, so it might be a pretty good all-purpose tool. And you could write it in any language that's available. Bash shell is probably available on any Linux system. You probably have Python, you may have Perl, and so on. Write a script. If you're doing an Apple system, then there are Apple forensic tools, but they tend to be really expensive, like Black Bag. And I don't know if Velociraptor supports Mac. It would be interesting to see, but it's kind of hard for us to do it in our classes because it's illegal to make a virtual machine running macOS as far as I know. Although it might be legal to run macOS on macOS in VMware Fusion. I know it technically supports it, but anyway, I don't have projects doing that right now, but it might be good to look into that. Anyway, Mac has a system profiler tool, and it has command line tools, a lot like Linux, that you can use. That'll record your hardware and your system logs you can get. And you have Unix tools, like date and dpackage, commands to see what's installed, disk commands, OS version and kernel version, and cron jobs to see what's running in the background, just like you do on Linux. And you can have services, user accounts, network connections, loaded drivers. There are command line commands to get all these things from the Mac, just like Linux, so you can write a script doing them. And that's all I've ever done, is just write a custom script for these things. PS gives you running processes. You can copy files and make tar archives of them. The system logs are, of course, all in var log, or I guess var ADM on the Mac, or private var log, that's right. But anyway, that's the whole, and you can get, of course, the command history, which is really important on Unix-based systems, often full of goodies in there. And you can dump the file system with LS and versions of that. Now, to make a direct memory image from a Linux or Mac-based system is not very easy. Maybe 10 years ago, Linux used to make it possible to just mount the RAM like any other disk and just directly read from it, but that's no longer supported by default. So the solution is Lime, Linux Memory Extractor. I used it for a project a couple weeks ago, worked just fine on Debian-based Linux. So I thought I might add that to this class, we'll see. But anyway, it turns out that you can add your own tool. The Linux Memory Extractor actually has to add a kernel module to your kernel, and it has to compile it separately for each machine. So you install it, and then you run it, and it compiles a kernel module, and then you have to insert the module. So there's a few steps, an insmod command to put it in, but it's not that bad, and it works like a champ. You get a perfectly good memory image. Although, if you actually compile it on the system you're getting the memory image from, that is, of course, a sloppy thing to do. What you ought to do, to avoid losing data more than necessary, would be get the information from that system telling exactly which kernel version you have, then compile the tool elsewhere and bring it in, I would think, to have the minimal effect on the memory. And here's DD is the main tool you use to collect data from any source, and you can just use it to collect dev mem. This is apparently the BSD-based systems still do let you just directly access the memory like any other device. You don't need to add the Lime kernel extension to do that, so that's nice. This is the way it used to be for all Unix-based systems, but most of them won't let you do that anymore. And there's Memorize for the Mac, of course, in principle, although I don't know how well it works. And there's something called G-Core, part of the GNU debugger, which you can use to dump individual processes on Linux, which sounds kind of fun. I haven't tried this, but it sounds like a fun thing to do. macOS license specifies it may only be run on Apple hardware. That's what I thought. Yes, you can run virtual systems on Apple hardware. That's what I thought. So if you have a Mac, you can run VMware Fusion and run a virtual Mac on your Mac, and that's legal. So I could write a project doing that for the Mac students, and it might be fun, but so far I haven't added that to any of my classes yet. Yep, good. And volatility supports Mac. Good. Volatility is looking better. For a while, volatility was kind of falling behind, but if volatility supports a Mac, it'd be very useful, especially for analyzing that RAM image, which is a huge problem. Once you get a RAM image, you need a real powerful tool to parse it and find things in there, and volatility would be good, but it has to have a custom configuration file for exactly every version of the OS, which has been a problem. And that's why, people that are not messing around, they pay thousands of dollars and get Black Bag, which, is the specialized Mac forensic tool, which will really do a good job, but you pay a lot of money for that. Mac has many fewer free tools than Windows. All right, so 7B, let's take a look at this. All right, grep first place. I bet that's Caitlin. That looks like a Caitlin name. Anyway, all right. All right, so which tool runs only on the Mac? Yep, that's System Profiler. Okay. Part of the tools that are taught in SANS. Oh, good. Yep, black bags and volatility. Good. Thank you. I appreciate the tip, because I can't afford SANS classes. I have to learn their contents from rumors like this. But good. Yeah, I know black bag is highly respected, but it's too expensive. Which one is the Mandiant tool? Like SANS. SANS and black bag are both highly respected and too expensive. Anyway, Redline is Mandiant's tool they talk about a lot. I couldn't get any good out of it at all. I tried. Now I think it's completely obsolete. As far as I can tell, volatility completely replaces whatever Redline would do. Anyway, I mean, not volatility, but Velociraptor. All right, so what tool runs on some Windows 7 machines, but not all of them? Python. Batch runs on every Windows machine. Batch files are the standard, that's all the way to MS-DOS. Python is the only thing here that you would find only on certain Windows machines, but not them all. You'd have to add that. And it's possible that you might have Python installed in your machines, like it's installed on that Windows 10 with tools we're using in my malware analysis class. But it's not on normal Windows machines. Aha! This reinforces my suspicion that this must be Caitlin. Anyway, all right, so. Which tool gathers RAM on Windows and Mac? Well, all right, memorize. Okay, I was thinking, oh, bash script won't run on Windows. Right, it's got to be memorized. Okay, fine. Now I'm catching on. You people are smarter than me on this one. All right. Well, I don't know who that is. In fact, we had that person before. Good. And Rohit we've had before. And K. I think that might be a K I know. I'm going to assume that unless contrary evidence appears, I'll assume that is the usual K I've seen before. All right.